So this is what are called compound inequalities. We just did single inequalities when we only had to solve one inequality. Compound inequality is when you take two inequalities, solve them each individually, and then instead of just having two individual answers, we're going to merge the answers together. Now you merge them by two different ways, with an and or. So we have to know what and or means, which we'll get to. So first of all, this is just a way to show you what and versus or is. I wouldn't necessarily write down the A and B thing. This is to get you to understand what and versus or is. This has nothing to do with what we're learning, solving in just a minute. All right, so we have a set A with numbers 1, 3, 5, 7, 9. This is set B with 1, 2, 3, 4, 5. We have two separate sets. All right, so and A and B, what this means, I would write down, and means intersection. So and is the intersection. You can see the word and written like this, or with this little upside down like U. Now, intersection is picky. How I remember that, and is picky, intersection is picky, is picky people aren't friendly. So frowny face, not friendly. So this one is really picky. Now think of it like this. Like, for example, if there's a clique, a group of friends or whatever, they're picky about who they let hang out with them, right? So in our answer set here, this is the picky friend group. They're only allowed if they're both in A and B. It's where they intersect. So let's look. Set A has a 1. Does set B have a 1? Yes. So 1 is considered to be intersecting. So 1. 1 gets to go. How about 3? Is it in both? Yes. How about 5? Okay, moving on. 7, 9, 2, 4. No, so it's picky. Do you see how and is the only where they intersect? Yes, where it's in both. Okay. Now, or is union. That means united. Everybody gets to go to the party, to the friend group. It's a uniting of A and B together. So we do the set. If it's in A, it gets to go to the party. If it's in B, it gets to go to the party. So 1, let's just go start with A. 1, 3, 5, 7, 9 gets to go to the party. Now 1, we're not going to list it again. That's double dipping. We already have 1, they're going to the party. 2, oh, we need to list it. 3, already got it. 4, we need to list it. 5, got it, and check. You guys see how it's uniting them together? Union friendly. Intersection picky. That's important to what we're doing next. Union versus intersection, and versus or. So the first inequalities we're going to solve are the and ones, the picky ones. So here's our first example, write it down. So in compound inequality is when you have two separated inequalities. Where you start is you solve them individually. So we're just going to go ahead and solve each individually. So subtract 2. We have 3x is greater than -9, divide by 3. So our answer for this side is x value is greater than -3. Now I'm going to write my answer in interval notation just to have it. So x value is greater than -3. Wouldn't that be then, it's going this way to infinity, isn't it? So it started at -3 and went to infinity, not including -3. That's the answer for this one, right? What we just learned 5 seconds ago. And 1.4. Are we good? Yes. Sorry, this is a greater, L greater than sign. Sorry about that. Now I want to give you a visual, okay? This is going to help for when we merge our answers. So let's just write out kind of what we're looking at. If we start at -3 and go to infinity, here are what our solutions kind of look like. We start down at -3, then we're going to infinity, so -2, -1, 0, 1, 2, 3, 4, and you get the picture going to infinity, right? Okay, let's go do the other inequality by itself. So you first focus individually. -1, 4x is less than or equal to 8, divide by 4. So x value is less than or equal to 2. Once again, let's write that in interval notation. Notice it's pointing to -infinity. So it's going from -infinity up to 2, and then it stops, and it's including 2. So let's get a visual like I did on this one for -infinity up to 2. So our top end was 2, so I'm starting up here at 2 with a bracket, and going down would be 1, 0, -1, -2, -3, ... going this way forever. Just giving myself a visual. Does everybody understand solving them individually? Now we're going to merge our answers together. Now this is an and one. And is picky. It's only where answers intersect. So if you see it in this set and that set, remember that's what gets to go in our final solution set, right? So let's see here. This one starts at -3. Is -3 in this one? Yes. Can we go past -3? No, because it started at -3. So the bottom end is -3, comma. Now we're going up this ladder here. What value do we have to stop at? 2. Doesn't it stop right here on this one? And it's the intersection. It's only where it's in both. You guys see how 2 is in both? Well, that's the stopping point. 2 is in both. That's the stopping point. So we went from -3 up to 2. The 2 got a bracket, the -3 got a parenthesis. Now look, it makes sense. Look, if I was to take this and just like merge them, do you guys see -3 up to 2? All good? All right, so let's put set notation. Now, this means our x values were between -3 up to 2. Everybody focus, this is always weird for people at first. So this is the first time we have to write a set where you'll see what happens. So we say the set for x such that we have to merge this into one answer. So what I would do is put x in the middle. Watch, I put x in the middle. What was the lowest value? -3. What's the highest value? 2. Now we have to put our munching alligator signs in the right direction. So you got to be really careful. Let's go back to here. Was this munching on the x or the -3? The x. So we go here. Do you guys see how I have to have it munching on the x? You guys see? Now right here, was it munching on the x or the 2? The 2. So that's how we would write our set notation. Now notice something here, our signs face the same way. That will always happen in this type of situation. This literally says x values between -3 and 2. All right, on our number line, what I would expect on the test is a 0, 2, -3. Then you can do close and open circles or brackets and parentheses. Let's just do brackets and parentheses to follow this trend. So parenthesis, bracket, and our solutions are right here. X values between -3 and 2. So it just takes a little thinking about merging these together. How do you guys feel about that? Hard, easy, okay, not okay? Decent. Yeah, it's kind of weird at first. It was for me back in the day. Let's do another one. All right. -2x plus 5 is greater than -1, and 5x plus 6 is less than or equal to -4. So we just solve them individually. Once again, -2x is greater than I meant to do -5. So that's -6. Divide by -2. We just divided by a negative, correct? So this is x values less than 3. So let's write that in interval notation. That would be -infinity up to 3 parenthesis, parenthesis. Giving yourself a visual if you need. So we started up at 3, then we're going down. So 2, 1, 0, -1, -2, ... forever. Okay, let's do this one. Subtract 6. 5x is less than or equal to -10. Divide by 5. X values less than or equal to -2. So then it's going this way, isn't it? -infinity up to -2. And then we get a bracket parenthesis. So what's that visual going to look like? Well, let's see. We're starting at -2 as our top end. So what's smaller than -2? -3, -4, on forever. Now these are intersection, right? And is intersect, picky. So let's see here. Do they both have a -4? Yes, they're both going to -infinity. Don't they have -infinity in common? So we gotta go until we don't have something in common. Do they have -4 in common? Yes. Do they have -1 in common? What did I do? That's why. Okay, so I said, do they have -4 in common? You said yes. And then when I said, do they have -1 in common? You said no. That is true. Okay, so where's the stopping point of commonality? -2, correct? So putting them together, we're going from -infinity. This one says interval notation. -infinity up to -2. Does -2 get included? It did in this one and in this one, so -2. So now our set notation is the set for x such that our x values are less than or equal to -2. See, this one wasn't bouncing between two values. Do you guys see how the merging was the -infinity up to the number? Okay, so just a little different. So our number line's the easiest part. 0, 1, 2. Let's do a closed circle. Going that way. Yes. Because it's not bouncing between two numbers. Like we would never write x between -infinity to 2 because infinity is not a number. The other one was bouncing between two numbers. This one just starts at -infinity and comes up to -2. So we can just say x value is less than -2. Does that make sense? Great question. Okay, let's go again. Okay. There's a reason I'm doing all these. It's not just to be up here. They all come out a little different, the answers. So let's do this one. So we would just solve them individually, add 5. X value is greater than 4. So then that would be 4 to infinity, parentheses, parentheses. So that would be like 4, 5, 6, 7, dot, 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 forever that way. Solving this one, we add 3 to x is less than or equal to -2, divide by 2. X value is less than or equal to -1. Well, that's going to -infinity. -infinity up to -1, bracket, parentheses. Now, what does that look like? Well, -1 is the top end. So then that would be -2, -3, -4, that way forever. Now, this one's and, so it's picky. It's intersection. Let's see, where do they intersect? Never. Doesn't this one come from -infinity up to -1? Doesn't it stop? This one. Then we have a jump, a gap. The next one starts at 4 and goes to infinity. Is there ever a place where they will intersect? No. So our interval notation is just no solution. We can't write an interval notation if there is no interval. No solution. Set notation, the set for x such that x has no solution. The number line we could draw, but it would be a no solution draw, right? So we don't need to draw it. We could to show there's no solution, but we could just say no solution again. That got stuck in my... Okay, all good? All good. All right, now here is one more fun fact for you. When you're solving, this is number 63 if you're curious. When you're solving, notice there's no and written. It's all merged into one. This is still a compound inequality. It's just they've already put it together. So if you ever see this type of situation, it's always and. And it will actually just work out. The math will work out to be an and one. You'll see why. So what we'll do is just solve for x. So we would need to subtract 2. Now you got to do it to each piece, each side of the equation. Do you see how I just did it to all of it? Make sure you do it to all of it. So then right now we have -6 is less than or equal to 3x is less than or equal to 8. Now get x alone, divide by 3, divide by 3, divide by 3. So we have -2 is less than or equal to x is less than or equal to 8/3. Now look, it's already, do you see how it's already setting it up for us for our set notation, everyone? So we remember this says the set for x such that x is between -2 and 8/3. So let's go do interval notation. That literally says x value is between -2 and 8/3. So where did we start? -2, people. Where did we end? 8/3. We get 2 brackets because they both have equal to signs. So on your number line, you could literally just go 0, negative 1, 2. Now, if you didn't know where the decimal fell of 8/3, couldn't you do 8 divided by 3 and see what decimal that is? What is it about? 2.6-ish, so we could just kind of, let's say it already was a number line for you, you'd go past, here'd be like 3, you'd just go about right there, you know what I mean? And then it was a bracket, and it's all the values in between. All right, good with and intersection, picky, merging the answers with a picky. Okay, let's do or, and then we'll be done. Okay, or. So or is friendly, either or gets to go. So you're gonna do the same thing, find the separate answers and then merge them together. So we would subtract 3, x values less than negative 2. So that would be in interval notation, negative infinity up to negative 2, parentheses, parentheses. Merging the answers. Then we add 2, x values greater than 5. So that would be 5 to infinity. Now, because it's or, it's friendly. If they're in this answer set, they get to go to the final solution. If they're in that answer set, they get to go to the final solution. So let's think about how we would, what's our solutions? Does negative infinity get to go to our solutions? Yeah, or is friendly. Is it negative infinity in this one, everyone? And then it gets to go up to negative 2, and then we got to stop, right? Then isn't it, there's a gap now between negative 2 up to 5. None of that's in our solution set, but then from 5 to infinity is in our solution set. So let's do our interval notation. Negative infinity up to negative 2. Then we jumped over, we skipped some values. We started from 5 and went to infinity. Now how we do it is we write union. It's uniting these answers together. So yeah, there is a gap of numbers that are not in our solution set because there was a gap for it. It didn't make sense. Or I mean, there wasn't a union. So our set notation with or, you actually just write them separately. So you'd say you don't merge them with or. So we'd say, because remember before with x, that when it was and, when it was bouncing between, we had to put it together. So with or, you can just say x such that x is less than negative 2. Or x can be greater than 5. So or gets to stay separated. So then on our number line, we would go 0, we would go negative 1, 2, we would go 1, 2, 3, 4, 5. So they both get parentheses or open circles going this way. Open circle, that's an open circle going this way. So what if this would have been an and one? Our answer would have been no solution. Do you ever see those squiggly lines intersect? Nope. Okay. Good. Another or one. We're almost done. Stick with me though. Hey. Do you guys want to try this one by yourself? Real quick. Make sure we're good. Okay, ready to go. So don't look up here until you get your final answer. So when we're merging these two, doesn't either or get to go? So what's the smallest value that starts us out here? 1. So starting with 1, what's our largest value? Infinity. Does everybody see how it ends up just being the one side, which will include it all? So our set notation, the set for x such that x is greater than or equal to 1. And then I think we get the idea with the number line on that, right? Was that one confusing for you? Was it pretty easy? Good to go? Okay, yes. Right, because if you, it would be kind of hard to, because then you'd be double dipping, right? 1, 2 is already included, and we're like, well, great, 2 gets to go here and here, great, and it's not intersection. So if it was intersecting, let's test you out. If it was and, if it was intersect, they do intersect in a lot of places, correct? But where would we have started with intersect? 2, right? Because this one has a 1, but this one doesn't. You guys see how we'd have to then go on to the next one. Intersect versus or. Okay, great. Okay, so let's just look at this fraction one, and then this last one is our last one. You're going to see where we have where we have an interesting thing happen. Okay, ready? How would we solve this one? Get a common denominator, right, everybody? Now remember, this 3/4 is the same thing as dividing all of it by 4, right? There's only one 4 here that needs to be. So you'd say I'm going to times by 4 times by 4. So then we would have 4, we don't need to worry about because we're solving. 3 parentheses x plus 4 is less than 24. Now, I personally would divide by 3, but that's just me. Could I distribute the 3? Yes, right? I'm going to just divide by 3. Divide by 3. X plus 4 is less than 8. Subtract 4. X value is less than 4. So that would be negative infinity up to 4 parentheses. All right, get a common denominator here, so I times by 2, times by 2. Our denominator can now be ignored. So we have 3x plus 1 is greater than 30. I would divide both sides by 3. X plus 1 is greater than 10. Subtract 1. X value is greater than 9. So then this one is from 9 to infinity. Everybody agree? Okay, let's put them together. Either or gets to go. Negative infinity up to 4. Then don't we have a gap? Yes. 9 to infinity. So interval notation. Negative infinity up to 4. Union 9 to infinity. Set notation. The set for x such that with the or, we get to keep them separated. X value is less than 4. X value is greater than 9. And I think you understand the number line thing. Yeah? Okay, the last one you need to see for a reason. This is the last example of the day. Then the rest of the time will be yours. Okay. Wait. Yes, it is this one. Okay, here we go. Solve for x. Times by, get a common denominator, times by 3, times by 3, yeah? Can I ignore the denominator now? Yes. X is less than or equal to negative 3. Well, if that's true, then that would be negative infinity up to negative 3, bracket parentheses. Go to the next one, add 1. X value is greater than or equal to negative 5. So that would be from negative 5 to positive infinity. Now remember, either or gets to go here. Is negative infinity in this one? And it definitely gets to go in our final answer, true? Yes. Okay. Now, we're going up, we're at negative 3. Is there a jump to negative 5 to infinity? No, negative 5 is like down here, correct? So where's our highest value going? Positive infinity, and we don't have to write them separate with the union because there was no gap. Does everybody see how they're overlapping? So it's like it's connecting all the way through. So negative infinity to infinity is interval notation, set notation, x, such that x is all real numbers. There's no way to write infinities with equal to signs. So right here, our number line, you would literally go like this on the text. And it goes forever, both ways. Okay, but be careful, because if you're uniting and there's a gap, remember how we did that. You know what I mean by gap, right? It was coming in, but then there was a jump, and then it started again. All right, that's the end of the lesson. Go practice 1.5. Don't go back to 1.4. Start on 1.5 while it's fresh on your mind. Practice and versus or.